Why don't you all please have a seat? Thank you for joining me, family.
You're welcome. Speech.
Do you know what it feels like to hold a billion of something? Right now, in your pocket, or most likely in your hand, your phone has 100 computer chips in it, which in total contain over a billion individual components. Working together, these give you functionality such as your audio and visuals, also your GPS, camera, and everything in between. I've been working with these devices and using them to build electronic circuits for 10 years now. I'm Riv Carpenter, and for a living, I get to play with microscopic puzzles, which our industry refers to as integrated circuits. Please join me for a quick glimpse of what is probably an unfamiliar world for you, but is responsible for many of the luxuries our society enjoys. Here is a completed package of an IC, courtesy of Texas Instruments. So what is an IC? Well, ICs, or integrated circuits, were conceived by Jack Kilby and Robert Noyce at Texas Instruments around 1958. They're used in nearly every electronic device. Most of them have one or more, depending on what function they need. You have functions for things such as sensors that are used to take any real-world reading and convert it to a digital signal. Then you have logic, which is the foundation of computers and programming. And power conversion, similar to like your USB plug, which converts a 20-volt signal in the wall to a 5-volt signal on your phone, and countless other uses. These are grown in labs, much like the quartz that's found naturally around the world. And they're produced in places just like DFW. So how is an IC constructed? Well, kind of like building a house. Sorry about that. First, you have a substrate, which is like the concrete foundation of your home. We grow silicon tubes about a foot wide and slice them millimeters thick. Each of these will house tens or thousands of individual chips. Next, you have diffusion, such as the in-wells and P-wells. These are like the rooms in your home, and define the floor plan. This is where your bedrooms, bathrooms, tennis courts, and wine cellars will lay. To make them, we shoot lasers at the wafers while bombarding them with various types of atoms. Certain devices limited to certain wells. Next, the devices sitting in and on top of the wells are kind of similar to your sinks, outlets, elevators, and tile warmers, which we commonly have in our homes. These devices are grouped together by their type and function. To connect these, we use metals, just like the plumbing and electrical that runs through your house. These metals are meticulously drawn, connecting these thousands or billions of devices in particular fashion. Lastly, we have the package. Just like the walls and roof of your home that protect you as a barrier against hail and tornadoes, these are served as a barrier against things in the micro world like electrostatic discharge. Also, they're a vehicle for your chip to sit in, for it to connect to a circuit board to the real world. So what does this mean for me on a day-to-day basis? Well, I draw these in a program, CAD type software, that uses a 2D bird's eye view, much like what you see here. We place components, tens of thousands of them, very carefully and very specifically, following rules. Then we connect them with our metals, run verifications on them, run verifications on the verifications, and then run some more just to be sure. And there you go. That's how your phone works.